All right, algorithms and flowcharts. What are algorithms and flowcharts?
An algorithm is a step-by-step procedure or formula for solving a specific problem or performing a specific task. It is a finite sequence of well-defined instructions that can be executed to achieve a desired outcome.
Very straightforward definition, I think. And you might note that an algorithm's definition is very similar to the function definition I gave a little while back, which is that it takes some defined output, does some stuff, and produces some defined output. An algorithm and function is very closely related. Algorithms can generally be one-to-one mapped to equivalent functions in any programming language, right? And a flowchart is just a graphical representation of an algorithm. There are some conventions as to what stuff means. All right, why are they important? Algorithms are important because they allow you to plan ahead of time. They allow you to just think about how stuff is going to be structured and catch any problems early on before you actually write the code. If you start if you start by jumping into writing the code, you might run into problems. Problems that might have been avoided and would have saved you time if you had thought it out and wrote an algorithm beforehand, right? Or even thought of an algorithm beforehand. Never jump right into code. Think or work it out on paper even better. Flowcharts. Flowcharts provide a visual representation of an algorithm or process, and they can be helpful from time to time. When you're explaining it to someone else or when you need a different view on something, flowcharts help. Like algorithms help because they let you think ahead of time. Flowcharts let you visualize stuff and see where something is going wrong if you can't figure it out from the algorithm or the code, right? Quick analogy. Architects don't just show up and say, build it like this. They plan. You are an architect of code. You plan using algorithms, right? Okay, let's take an example algorithm to find the maximum of two numbers. You take input two numbers and then output maximum of the two numbers. If A is greater than B, you just output A is the maximum. If if A is not greater than B and A is equal to B, A and B are equal, else output B is maximum, right? I'm pretty sure I don't need to explain like what if and else if do in this specific case here. Obviously, algorithms can be a lot more complex and probably will be a lot more complex. And as for flowcharts, you have a few conventional diagrammatic representations, right? An oval represents the start and end. Rectangle is a step, essentially. Diamond is a decision point. So A greater than B, do something. If A is equal to B, do something. Otherwise, do something. That represents a decision point, right? Those are represented using diamonds. Parallelograms. Parallelograms represent input and output. So we have to get input A and B, right? And then you have to output the maximum, or if they're equal. And then arrows uh, point from the previous step to the next step. All right. Let's just do a quick flow chart of the above process, right? We start and then we get input for A and B. This is a parallelogram, not a rectangle. Don't add me. A, B. And then you have a decision point. A greater than B. Yes. Now you output A, right? No, A is not greater than B. We check if that is a diamond. Don't add me. A equals B. Yes. A equals B. That's supposed to be a parallelogram. My bad. And then finally, that's no. You check if actually you don't check because at this point you know that B is the greater one, right? And then you end the program here. And then if A is equal to B, you end. And if A is the greatest, you also end, right? So this is a simple flowchart. It is very ugly, I know. Excuse the handwriting. And that's it for flowcharts and algorithms. See you in the next video.